Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 9 video on the chapter of mensuration, where I will discuss about how to find the area of a given shaded region, the region which is formed by overlapping one or more overlapping rectangles or squares. If you have not watched the previous part 1 to part 8 videos on this chapter of mensuration, then I strongly suggest and request that you please watch those videos also to maintain your continuity on your study on the chapter of mensuration. I will also include the concept practice problem set number 2. The link of the PDF will be there in the description below. So the problems of set number 2 is also based on the area and perimeter diagonal of squares and rectangles and the area of 4 walls of a room. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so in this video we will discuss about how to find the area of a given shaded region, and the region is made up of one or more rectangular or square figures. In future, when I will cover how to find the area and perimeter of other figures like triangle, parallelogram, rhombus, circle, then we will also learn how to find the area of a shaded region, which can be decomposed into various figures like circles, rhombus, parallelogram, squares and rectangles. But in this video I will only discuss a shaded region, to find the area of a shaded region which is formed, which can be decomposed into rectangles and squares. Okay, so there are some basic steps which are used to find the area of a shaded region. Now these are it is not the fact that these steps are the precise steps or exact steps that you need to follow, but more or less this will give you a good idea how to start to find the area of the shaded region. So the steps are: divide the shaded region into multiple rectangular or square figure. So let's say there is a shaded region. Let's take for example this one. So this is one of the illustrative example that I will I will explain. So let's say, as you can see, the shaded region is highlighted with a gray color. So in this, we have to find what is the area of as you can see that the shaded area can be made up of many rectangular or square figures. So the first step is you divide the entire region into multiple rectangular or square figures. And square figures, let's say those figures I am referring as figure F. The second step is that once you have decomposed the entire shaded region into multiple rectangles and squares, you need to identify whether any rectangular or square sub area which are overlapped by two or more figures that you have formed in the step 1. That is, from the step 1, if you see that two or more figures are having an overlapping region, that is a common region to two or more figures, then those area or regions you need to identify, and also you need to identify how many times those regions or area are being considered. For example, if you see that two figures from step 1, two rectangular or square figures from step 1 is having a common region A, then the n will be 2. Because n is nothing in step 2. N is nothing but the number of figures F from step 1 that are having the common sub area or region A. Okay. Now in step 3, we will add up the areas of all the figures that we have formed in step 1. let's say this area be A1. All the figures in step 1 will be a rectangle or a square. So A1 is the sum of all the figures F that are being formed in step 1. In step 4, we will find the sum of all A multiplied by A minus 1. But now what is A? A is the area. A is the area of a sub area that is identified in step 2. And if that area is being, for that area, if n is the number of figures to which the area is common, then we will find the product A multiplied by A minus 1. And so A multiplied by A minus 1, we will find all these values for all the sub areas A that is identified in step 2, and we will add them up and let the sum be A2. Now A1 minus A2 will be the required area of the shaded region. Now what we are actually, why we are subtracting, what is A2 and why we are subtracting A2 from A1. Now A2 is nothing but, A2 is the sum of all values of A multiplied by A minus 1. What is A? A is the area of a sub region or overlapping region. And what is N? N is the number of figures to which this sub area is common to. So basically, when we are if we just add up in A1, the concept is that in A1, what is A1? A1 is the sum of all the rectangular or square figures F found in step 1. If we just add them up in A1, what will happen is the overlapping areas will be considered more than once. So we need to consider the overlapping areas only once. So essentially we are subtracting the sum of all the overlapping areas which has been considered more than once from A1. So that is step 5, A1 minus A2. That is why we are subtracting A2 from A1. Now please do not worry much about these steps. It will be clear when we will solve problems. Now one thing to note is that in step 1, when you will divide the shaded region into multiple rectangle or square figures F, please, it is preferable if you form the figures F so that they do not have a overlapping region, because as you can see, if they have overlapping regions, then there is an overhead, there is an extra work to find A2, and then you have to again subtract A2 from A1. But if in step 1, if all the figures, if they do not have any non-overlapping, they do not have any overlapping region, then simply if we add up the area of all the figure F, then that will be the area of the shaded region. Okay, now let's see some shaded region. I have 4 examples, illustrative examples, and let's see how we can find the area. These are not actual problems. As you can see, the dimensions given are just I have used some variables. You can consider in this figure, example 1, you see the shaded region. In most cases, okay. So one more thing, whenever you are given a shaded region, sometimes it is better if you draw the rectangle. If you draw the rectangle inside which the entire shaded region can be considered, you just draw a rectangle so that the entire shaded region will be inside that rectangle. So in this and always name the corners of the shaded region. Always name the corners of the shaded region, which will help in identifying all the rectangular figures F that you will form in step 1. So let's say in this example, the shaded region, as you can see, we have to find the area. So I have enclosed the entire shaded region in the rectangle A, B, C, D. So the shaded region is enclosed I've enclosed inside the rectangle ABCD. Now in the problem, the ABCD rectangle may also be given and may not be given. And also you can see the dimensions of the shaded region are given, like the vertical, horizontal, as you can see the rectangle also. Okay, so also name the corners of the shaded region. So let's say this point be E, this is E, this is F, and this is G, this is H, and this is I, this is J, and this is K, this is L, and let's say this is M, and this is N. So always name the corners of the shaded region, so that it will be easy to refer the rectangles that you will form in step 1. Okay. Now there are various ways of how to find the area of the shaded region depending on what dimensions are available. For this you can see that the dimensions of the enclosing rectangle, that is ABCD, are given. The length is x and the height or the width or so we have here BC is equal to AD, since it's a rectangle, is given as x. Now x, y, m, n, these are all in units. I am not considering a specific units, just assume that they are x units, y units, n units, and m units. Okay, and we have the width of the rectangle is AB is equal to DC is equal to y. So these are the dimensions given in the problem, in the figure. What else is given? We are given. Okay, so we have we need to name few more points. So I have up to I, J, K, L, M, N. So let's say this point be O, this point be O, and this point O P, this point be Q, and this point be R. Okay, so I have the width of the horizontal shaded rectangle, as you can see, is that is QR. QR is equal to OP is equal to given as N, and I have MN. MN is equal to KL is equal to M. So these are only the dimensions given. Now, okay. So as you can see that you can clearly see we can the entire shaded region. So entire shaded region I can divide into two rectangles. The one rectangle will be MKLN. So MKLN. Okay. So let's say so one rectangle. Okay. Let's say what? How will I explain? So in step 1, as you can see, in step 1, what we are doing dividing the shaded region into multiple rectangular or square figure F. So let's say I am listing how I am dividing F's. F's means all the figures, that is all the rectangles or squares into which I am dividing the entire shaded region. So I will divide the entire shaded region into two rectangles. The first rectangle is rectangle M K L N, and let's ignore the word rectangle. I hope it's understood. So the first rectangle is M K L N, and the second rectangle is O P R Q. So these are the two figures that I've divided the shaded region into these two rectangles. Now clearly you can see that these two rectangles have a overlapping region. So what are the overlapping regions? The overlapping areas, I said that in step 2, identify any rectangular or square sub area A which are overlapped by two or more figures from F. Okay, so let's say A is P, the overlapping areas. As you can see, the overlapping area in this case is the rectangle GHIJ. It is the overlapping area or sub area or region. Now also I can see that for this overlapping region n is equal to 2, because this overlapping region is common to the only two rectangles MKLN and OPRQ. Okay. So now what will I do next is I will find what is then will be A1, that is the area of all the figures F that I have formed in step 1, that is the area of rectangle, area of MKLN plus area of OPRQ. This will be area of MKLN. As you can see, for the rectangle MKLN, the length is y. The length is y, so we have y multiplied by, and the width is m. And the area of OPRQ. Now what will be the dimension of OPRQ? So OP is equal to we know is n. OP is n. So OP we already know. We have written QR is equal to OP is equal to n. What will be HI? HI is the length of the OPRQ. Okay, so the rectangle OPRQ, the area will be, the length is x and the width is n. Okay, so this is equal to ym plus xn. Now please note that I am not trying to give any formula. I'm just explaining some example figures with some variable dimensions, and explaining how you can divide the shaded region into some rectangles and squares, and based on the given dimension, and how you will eventually find the total area of the shaded region depending on whether there is any overlapping or non-overlapping areas or rectangles. Okay, so this is A1 is ym plus xn. Okay, now what is since we have overlapping sub areas or regions, which is the rectangle GHIJ, I have to find A2. What is A2? A2 is the sum of all the sum of area of sum of the area of sub-region multiplied by n minus 1. So we have only one sub-region, which is GHIJ, which is the rectangle GHIJ. So A2 will be area of GHIJ multiplied by n, its n minus 1. Now n for the area GHIJ, the value of n for the sub-region or the overlapping region GHIJ is 2. Now what is area of GHIJ? The rectangle GHIJ will be, the length will be, as you can see, what will be the length? The length is m, and the width is n. This multiplied by n is 2 and minus 1. So this is equal to mn. So therefore the area of the shaded region, area of shaded region will be equals to A1 minus A2, which is equal to ym. A1 is ym plus xn minus mn. So whatever the value will be, because in the actual problem the values of ym, x will be given in some units. So this will be the area of the shaded region. Now in this problem can we divide the shaded region into rectangles which do not have any overlapping regions? Can we do that way? Now, I will leave it to you. I will leave it as an exercise. If from the given dimensions, that is y, x, m, and n, can you find the area of the shaded region by dividing the shaded region into rectangles and squares so that they do not have any overlapping regions. If you can, please do let me know in the comment section. I will highly appreciate that. And if there is a possibility, if it is possible to divide the shaded region into rectangles and into two or more rectangles which do not have any overlapping regions, then I will also try to create a video for that solution. As it is always preferable if you can, in some problem the dimensions will be given in such a way that it will not be possible to divide the shaded region into rectangles or squares which will not have any overlapping regions. Okay, it will depend on the shaded region and the given dimensions. Okay, let's see the next problem. Illustrative example. So as you can see, the shaded region is the is like a stair. So basically, let me we have to find the area of the figure like this. So this is actually the shaded region. So roughly I am drawing it. We have to find the area of this. This is the shaded region, and some dimensions are given. As you can see that, let's say only this shaded region was given. So for the sake of easiness of understanding, I have enclosed the entire shaded region in a rectangle. Let's say the enclosing rectangle be A, B, C, and D, and then I must for the easiness of calculation, I must name all the corners of the shaded region. So let's say the corners be, let's say this be E, let's say this be F, this point be G, H, I, and yeah, okay, and I, and let's say this point be J, and this point be K. Okay. So now how will I divide the shaded region into rectangles and squares? It will depend. Now please mind that you have to appropriately divide the shaded region into rectangles and squares whose dimensions you know from the given dimensions. Obviously you will not divide the shaded region into some rectangles or squares whose dimensions you don't know, because eventually you have to find the area of all those rectangles and squares. Okay, now okay, let's see. As you can see, if I divide, let's say I'm dividing the region into some rectangles and squares. So the figures F's, all the figures F's will be, let's say the rectangle E F K D, and then I'm trying to divide the entire region into rectangles or squares so that they will not have any overlapping regions or overlapping sub area. So the first figure is the rectangle EFKD, and the second one is GHJK, and the third one is IBCJ. So you can clearly see that these rectangles EFKD and GHJK and IB, CJ, they do not have any overlapping region. That is, no two rectangles, no two or more rectangles have a common area region. Okay. So basically, I can say this is none. We do not have any. We do not have any overlapping sub areas. So I can say in this case A2 will be equal to 0. What was A2? A2 was the sum of A1, sum of A1, sum of A1 into n minus 1, where A, sum of A into n minus 1, where A was the area of a sub-region and n was the number of figures from F's which are having that common sub-region. So in this case A2 will be 0. Now let's find what is A1. So A1 is the sum of all the sum of areas of all the rectangles of all the rectangles or squares that we have formed in step 1, that is into which the rectangles and squares into which we have divided the entire shaded region. Okay, so this will be area of EFKD plus area of GHJK. Now please bear in mind that I have, even though I have divided the shaded region into the rectangles EFKD, GH, JK, IBCH, it should be possible. I must know the dimensions of all these three rectangles. Because eventually I have to find the area of all these rectangles. I hope I can, because I was not really that conscious. Let me quickly check. EFKD, the EFKD, I know what is DK. Okay, DK is n, and what will be FK? Okay, ED is P and FK is n. No, not FK, but DK is n. So for this, I know the dimension is what will be it is P by P into n. Okay, and for this rectangle GHJK, what is the length? The length, please note that the length will be x minus L. Please carefully, you have to observe the given shaded region very carefully, and what are all the dimensions given. Based on that, it will be based on that only you should divide the shaded region into appropriate rectangles and squares, so that you know their dimension. So GHJK, the length will be x minus L, and its width will be as I can see its width will be a y minus n minus m, y minus n minus m. Okay, and this one IBCJ, the rectangle IBCJ, the length is x and the width is m. Okay, so we have plus area of IBCJ. So this will be area of EFKD. Since its dimensions are P by n, I can say that its area will be Pn plus the area of GHJK, the length is x minus L, and the width is y minus n minus m, plus I have the area of IBCJ, the area will be x into m. So whatever this value will be, so this is the area of the shaded region. I hope you are getting the idea how I am dividing the given shaded region into rectangles and squares, so that I know their dimension from the given dimensions in the problem. Now, sometimes you may find that sometimes you may find that instead of dividing the shaded region into multiple rectangles and squares, you can find so there will be, if you enclose the entire shaded region in a rectangle, possibly in most of the cases there will be some blank area in this, that is the white spaces. So if you subtract, so the area of the shaded region, so you can also see that area of shaded region, this is also this is another method of finding the area if possible. It may not be possible all the time, given on the best, it will heavily depend on the given figure and the dimensions given. So area of shaded region, you can also consider this to be the area of enclosing rectangle, in this case ABCD, enclosing rectangle minus the area of blank region or empty region, or you can say blank, empty or unshaded region. Now for this, what you will know, in most of the problems you can easily find the dimension of the enclosing rectangle. That is, in all these illustrative examples, I am referring the enclosing rectangle as ABCD. So the dimension of ABCD you can easily find out in the given problem. So you can easily know the area of enclosing rectangle. So I just need to find somehow the area of the blank, empty or unshaded region. Now if you, for this illustrative example number 2, what will be the unshaded region? That is the figure. What is the figure of the unshaded region? It is AI, H, G, F and E. So this is the unshaded region. So if you subtract the area of the unshaded region from the enclosing area of the enclosing rectangle, that will also give the area of the shaded region. So somehow now it must be possible for you to find the area of the unshaded region, depending on, sometimes it will be, you can find it out based on the given dimensions. So again, so to find the area of the blank or empty or unshaded region, the concept will be same. You can also divide the blank, the entire blank region into multiple rectangles and squares. The concept of finding the area of the unshaded region will be same as the concept of finding the area of the shaded region. Now, why am I even discussing the fact of this concept, that is the area of shaded region is equal to the area of enclosing rectangle minus the area of blank region? Because in some problems you will see it is highly possible that it will be easier to find the area of unshaded region or area of blank region. Then it will be easier to find the area of the blank region than to find the area of the shaded region. In that case, you can find the area of the blank region and subtract that from the area of the enclosing rectangle. So this is another possibility of solving this kind of problem. It will depend on the given figure and the dimension. Okay, so let's say, can I apply this concept to find the area of the shaded region? Let's see if I can find the area of the unshaded region. So if I join this, and let's say this point B, I have J, let's say this point be T, let's say this point T. I am trying to find the area of the unshaded region, that is a blank region. So area of unshaded region is equal to, I can say, area of the rectangle ATFE plus area of the rectangle TIHG. Okay, this will be what is will be the area of ATFE. ATFE, it will be, the length is x minus p. The length will be the rectangle ATFE, its length is x minus p. And what is its width? Its width is n. Okay, so this is the area of rectangle ATFE. What is the area of rectangle TIHG? TIHG. It will be L multiplied by the width IH is the one side, and the other side is will be y minus m minus n is equal to GH. So this is the area. So as you can see, the unshaded region, we used two rectangles to find the area of the unshaded region. So this implies, I can say, area of shaded region will be equal to the area of the enclosing rectangle, which is yx minus the area of the unshaded region, which is x minus p n plus this. So this is another way of finding the area of the shaded region. If you find that it is easier to find the area of the unshaded region, then you just subtract the area of the unshaded region from the area of the enclosing rectangle. Okay, let's see the next example. Okay, so as you can see, we are having an enclosing, the enclosing rectangle is already given, and we see we have to find the area of the shaded region. So let's say the enclosing rectangle is A, B, C, D, and I will also mark all the corners of the shaded region. So A, B, C, D, let's say this is E, F, G, H, I, J, K, L, M, N, okay, Mn, and also O and P. Okay, so now let's see. As you can see that the shaded region, now you can see that the entire shaded region is composed of four rectangles. This one, this one, this one, and this one. Now, so if you can find the area of these rectangles and then you will add up, that will be the area of the shaded region. That is one way. Another way is that if you can, which will be more easy, you have to decide. Another way is that you find the area of the unshaded region, which you can also think of two rectangles having an overlapping area. So in the first method, if you just think of the shaded region as the four rectangles, you have to find the area of, you have to find the dimensions of the four rectangles and find the area and sum them up. But if you apply the second method, that is, if you find the area of the unshaded region and then subtract that from the area of the enclosing rectangle, I think that will be more easy. So let's say method 1, I am in method 1, that is, I will find the area of the unshaded region and subtract that from the enclosing area of the enclosing rectangle. Okay, so to find method 1, finding area of unshaded region, unshaded or blank or empty region. So I will now find the area of the unshaded region. Okay, so what are the concept of finding the area of unshaded region is same as the concept of finding the area of the shaded region. We will divide the area into some rectangles and squares whose dimensions we can identify, we know. Okay, so what will be the f's? That is the I will divide the unshaded region into some rectangles or squares. So let's say I am dividing the unshaded region into the rectangles G M N H and the rectangle E J P O. Okay, clearly these two rectangles have a overlapping rectangle. So the overlapping areas or overlapping regions is the rectangle F K L I. Okay, now what will be A1? What will be A2? That is the what will be A2? That is the sum of the product sum of A multiplied by A minus 1, where A is the area of a overlapping region and N is the number of figures. N is the number of figures which are having that overlapping region as a common region. So in this case, A2 will be, since there is only one overlapping region, which is the rectangle FKLI, A2 will be area. Okay, for the overlapping region FKLI, what is N? N is equal to 2, since it is common to only two rectangles GMNH and EJPO. So N for the overlapping region FKLI is 2. So A2 will be area of FKLI multiplied by N minus 1, and this is equal to, what is area of FKLI? FKLI, its area will be KL into KL into IL, and this whole multiplied by N for this is 2, so 2 minus 1. Okay, this is equal to, what is KL? KL, we are not given the how do we know, how can we find the length of KL? You have to observe the figure and what are the given dimensions. KL will be KL, as you can see, there are what are the dimensions given? The dimensions given are the length of the enclosing rectangle, that is x, the width of the enclosing rectangle, that is y, AG is given, which is P, HD is given, which is Q, OP is given, which is M. So KL will be BC minus JK minus LP, and 2 minus 1 is 1. Okay, now what is BC? BC is X, and what is JK? JK is P, and what is LP? LP is Q. So this is Q minus X minus P minus Q. This is A2, and what is A1? And what is A1? That is the sum of the areas of all the rectangles that you have formed in step 1. That is into the rectangles into which you have divided the entire region, that is, we are considering the unshaded region, those rectangles, the sum of those rectangles. So which is A1 is area of the rectangle GMNH plus area of rectangle EJPO. This is equal to area of rectangle GMNH will be GM multiplied by NH. And what will be the area of EJPO? The rectangle EJPO, it will be EJ multiplied by JP. This is equal to, what is GM? GM is the width of the enclosing rectangle, which is Y. And what is NH? Sorry, the area of the rectangle GMNH will be GM multiplied by MN, not NH, but MN. And MN will be, MN is nothing but X minus P minus Q. And then plus we have EJ multiplied by JP. What is EJ? EJ is M. And what is JP? JP is the length of the enclosing rectangle, which is X. So we have found A1 and A2. So so now this will imply that area of unshaded, remember that we are finding the area of the unshaded region. Area of unshaded region will be A1 minus A2, which is equal to Y into X minus P minus Q plus MX minus X minus P minus Q. So this implies finally what will be the area of the shaded region. Area of shaded region, area of shaded region will be equal to the area of the enclosing rectangle, which is Yx, and the area of the unshaded region, which is Y into X minus P minus Q plus Mx minus X minus P minus Q. So this is finally the area of the shaded region. So this was, I used the method 1 where I have found the area of the unshaded region, and then I have subtracted the area of the unshaded region from the area of the enclosing rectangle. Now you could have in another method, I can, if I can also divide the, as you can see, the shaded region is already divided into 4 rectangles. If you can find the dimension of all the 4 rectangles, then you can also add their areas. Now let's see in the method, I really don't have any space. Let me shift the example 4 to the next page, and let's try to in method 2. I will in method 2 I will find the area of the shaded region directly by dividing the shaded region into rectangles and squares, whose area I can find, and from the given figure it is quite evident that it is already divided into 4 rectangles. So in method 2, area of shaded region will be equal to area of the rectangle AEFG plus area of the rectangle HIOD plus area of the rectangle JBMK plus area of the rectangle LNCP. Now, one thing to note that you can clearly understand this kind of small observation you must make, or you must be able to do. You can okay, one thing. Okay. The thing I was trying to say is that it is quite possible. It will depend on the dimensions given, that the shaded region, the shaded region, that is the rectangle on the top left corner, that is equal to, that is the area, that is the rectangle AEFG is congruent to the rectangle JBMK, which in this problem is not the case, but in some problem it could be the case that AEFJ and JBMK are congruent. So you must clearly understand and identify if any two rectangles are congruent or not. Because congruent rectangles will have the same area, you have to apply that concept. If that is the case, if you found any two rectangles are congruent, then you must it will ease up the calculation if you consider their area to be the same. Okay. And okay, so what is the area of AEFG? The rectangle AEFG, the length is P. The length is P. This is equal to P. AEFG. The length is P, and the width will be GF. Can I find GF? GF. I don't think I will be able to find the area of the shaded region in this method, because for the rectangle AEGF, I don't think I can find the length of GF. Based on the given dimensions, I don't think I can find the length of GF. OP is M, fine. The entire width is Y. That's all I know. No information is from the dimension of Y and M. I cannot find what will be the length of GF. Let me see GF. Okay, let me see what it comes out. So we have area of AEFG. AEFG will be the length is P, and let's say multiplied by the width is GF. We don't know as of yet what will be GF. Let's see. So I'm just keeping it like that. What is area of HIOD? HIOD. The width is Q, and the length also I do not know. So Q multiplied by OD, even though I know that OD is equal to GF. Anyway, let's see. And then we have plus area of JBMK. Area of JBMK. JBMK. The length is P, but I do not know what is MK. Okay, so I have to write P into MK. P into MK. Okay, and finally, what is the area of LNCP, rectangle LNCP? LNCP. NC is Q, and I don't know what is PC or LN. So let's say it is Q into PC. Q into PC. Now, if I simplify this further, let me see if eventually I can find the value. So if I take, so this is if I take, if I simplify and if I consider the first and the third term and take P common, I have P multiplied by GF plus MK plus I have Q multiplied by OD plus PC. Do I know GF plus MK? GF plus MK. GF plus MK, yes, I know. GF plus MK, GF plus MK will be Y minus O. Okay. This is equal to GF plus MK will be Y minus M. This will be Y minus M plus Q. Do I know OD plus PC? OD plus PC also I know is Y minus M. It is Y minus M. So this is equal to Y minus M multiplied by P plus Q. Okay. So I was also in method 1 also, using the method 1 also, we were able to find the area of the shaded region. That is, if we consider the shaded region, if you divide the shaded region into some rectangles and squares, which it is already divided, that way also we can find its area. So, to solve this kind of problems, it will heavily depend on the figure given and the dimensions given. But remember that in most cases you will be able to enclose the entire shaded region in some rectangle, and then you have to decide whether it will be easy to find the area of the shaded region directly, or you find the area of the unshaded region and then you subtract that from the area of the enclosing rectangle. Let's see the last example. So we have this kind of figure. As you can see, the shaded region, the figure shaded region is something like this. Approximately, this is the shaded region whose area we have to find based on the given dimensions. So the first thing you must always do is you form the enclosing rectangle, and then you name the enclosing rectangle, let's say A, B, C, and D, and also all the corners of the shaded region. A, B, C, D, let's say E, F, E, F, G, H, I, J, J. Okay, let's also name I, J, K, L. Okay, K, L. Okay. So now, how do we find the area of the shaded region? Now, clearly, the initial step or method or the idea will be to divide the shaded region into, as you can see, into 3 rectangles. 2 are horizontal and 1 is vertical, and they will have some overlapping areas. Now the formation, the dividing the shaded region into rectangles. How you are dividing the shaded region into rectangles will in what rectangles will heavily depend on the dimension given, because when you are dividing the shaded region into rectangles or squares, the dimensions of those rectangles and squares should be available. You must be able to determine their dimensions because their area need to be found. Okay, now let's first use the method where we directly find the area of the shaded region. So I have this n. R Q. Let's see if I can divide the shaded region into some rectangles or squares which do not have any overlapping areas. So method 1, I am using directly dividing the shaded region into some rectangles and squares. Okay. With no overlapping areas. Okay. So what will be the ifs? That is the all the figures, all the rectangles and squares into which we are dividing the shaded region, considering the fact that they will not have any overlapping region. So let's say one be the rectangle A. I am not sure. Now I have to be very careful in forming the rectangles or dividing the shaded region into rectangles, so that I must be able to know their dimensions. So if I consider the rectangle AEFG as one such rectangle, I need to know EF is already given to be R, okay, and FG we already know is Q. Okay, so I know the dimension of, that is the length and breadth of the rectangle AEFG. Okay, next let's say if I consider the rectangle G, let's say this be KL, let's say this be M, this be N. So let's say the rectangle, the next rectangle be GMNH. So these two rectangles AEFG and GMNH, they do not have any overlapping rectangles. Now I must see whether I can find the dimension of the rectangle GMNH. GM is the length, which I know is the length of the enclosing rectangle, which is Y, and MN I also know it is given as small n. Okay. Now the last rectangle will be JNCI. Let's see if I can find its dimension. NC, and the length will be NC. Do I know NC? NC is, yes, I know NC. NC will be X minus R minus N. Okay, I know. And what is IM? What is IC? IC is given to be small m. Okay, so I know the dimension of all these rectangles, and all these three rectangles do not have any overlapping regions. So so what are the overlapping regions? They are none, as all the figures from F, that is the rectangle AEFG, the rectangle GMNH and JNCI, none of them have any common regions. So the list of overlapping regions is none, 0. So this implies that A2 will also be equal to 0. Now we must find what is A1. A1 is the sum of areas of all the figures from F's, that is the sum of the area of all the rectangles and squares into which we have divided the shaded region. So this will be area of AEFG plus area of GMNH plus area of JNCI, and this is equal to, what is area of AEFG? The rectangle AEFG is AE multiplied by EF. What is AE? AE is Q. And what is EF? EF is R. Okay. Area of GMNH. GM multiplied by MN. What is GM? GM is Y, and MN is small n. Okay. What is the area of the rectangle JNCI? JN multiplied by NC. What is JN? JN is M, small m, and NC is NC we have to calculate from x, it will be x minus r minus n. Okay, so this will be and so therefore this implies area, since A2 is 0, area of shaded region is equal to A1 minus A2, which is equal to A1, which is equal to, in this case, QR plus YN plus M into X minus R minus N. So this was, in this method we divided the shaded region directly into some rectangles or squares which do not have any overlapping regions, as it was possible to divide the shaded region into some rectangles which do not have any overlapping areas. In some problems it may not be possible to divide the shaded region into some rectangles or squares which do not have any overlapping areas. There will be some overlapping areas. In that case you have to appropriately find the area. Now let's see in another method, in method 2, if we can find the area of the unshaded region and subtract that from the area of the enclosing rectangle. Let's see if it is possible. It may not be possible, it will depend on the given figure and the dimensions. Method 2, that is, we are trying to find the area of the unshaded region. So we are trying to, how can we divide? So we can clearly see that the unshaded region is already divided into two rectangles. Now it is important to, now we need to see whether we know the dimensions of the two unshaded rectangles. So definitely the rectangles will be, the unshaded rectangles will be EB, MF and HJID. So these are the two rectangles that are forming the unshaded region. We need to see whether we know their dimensions. EBMF, we need to know EB. How do we know EB? EB, it will be area EB. We also need to know BM. BM we know it is R. BM is R. So let's see. Okay. Now F's is this, and since there are no overlapping regions, the two unshaded rectangles, they are not overlapping, so we do not have any overlapping regions. Okay, so this implies A2 is equal to 0. So now what will be A1? A1 will be area of EB, the rectangle EBMF plus the area of rectangle HJID. What is the area of rectangle EBMF? EB, we do not, as of we do not know EB. Let's say EB multiplied by BM. EB multiplied by BM. BM we know is given as R, plus area of HJID. Do we know HJ? We know HL. HL is Q. HL is Q. From Q. Okay. HJ, what is HJ? HJ is y minus m. HJ we know is y minus small m is HJ. HJ is y minus small m. And what is JI? Do we know JI? JI. Yes, JI is equal to x minus r minus n. We know x minus r minus n. So we just need to know what is EB. can we find somehow EB? Oh, we know EB. We know EB. EB is y minus q. Sorry, EB is y minus q. EB is y minus q. We have R plus y minus m multiplied by x minus r minus n. So in method 2 also we can easily find the area of the unshaded region. So this implies what will be the area of shaded region. The area of shaded region will be equal to the area of the enclosing rectangle, which is yx minus the area of the unshaded region. Area of the unshaded region, which we have just found to be y minus q multiplied by r plus y minus m multiplied by x minus r minus n. Okay, so I think it is now clear how you will solve to find the area of some shaded region which can be decomposed into multiple rectangles or squares. Either they may have overlapping areas and they may not have overlapping areas. So sometimes it is easy to directly divide the shaded region into some rectangles and squares and apply the strategy and the steps that I have discussed, or it will be in some problems it will be more easy if you to find the area of the unshaded region and then you subtract that area of the unshaded region from the area of the enclosing rectangle. In most of the problems, I think you can easily form the enclosing rectangle of the given shaded region. I hope this video was beneficial in understanding and applying the concept of how to find the area of shaded region which can be decomposed into rectangles and squares using method 1 and 2, that is either directly finding or dividing the shaded region into rectangles and finding the area, or by identifying the unshaded region and finding its area and then subtracting that area from the area of the enclosing rectangle. In the next video, I will solve the problems of exercise 20b, which will be based on the problems of finding the area of shaded region as well as finding the area of a path constructed along a rectangular plot outside or inside, which I have discussed in the previous video. So in the next video, I will solve problems of exercise 20b from the textbook of author RS Aggarwal. If this video was beneficial, please like it, share it with your friends, and if you have any kind of question or query, please feel free to use the chat box to let me know your queries or doubt. I will highly appreciate that and I will do my best to answer all your queries. So please like this video if this video was beneficial, and also support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.